CNC Talk with Jatinder.
Morning, everyone. So here is another podcast. So hopefully, first of all, I'm just looking outside the window here. The weather here in Sydney, it's a bit windy today, so we're supposed to be sunny, I guess. But anyways, hope everyone's doing well. And hey, Ben, how are you doing, mate?
Yeah, really well. Settling in here in Canberra, so yeah. Not doing well. Cold here, but that's no news.
Yeah, Sydney should be warm compared to you then. Right, great. So yeah, hopefully everyone's been doing great. Thanks for joining in today. I can see already we have quite a few people here, about 20 or so, and a lot of them are from I think overseas. So thank you everyone for joining in, taking out your time, and putting in the feedback for the topics. And we've been getting a lot of questions about motors, people trying to do retrofitting or build up a new machine. Questions always coming about stepper motors and servo motors. So we thought, okay, while we got Ben here, who's making machines, using motors on his machines, probably the best person to ask this question. So I guess I'll be asking more questions, Ben, and kind of be relaxed a bit today. And sure. But I think it's going to be an interesting one today. It's quite a good topic. We had a kind of a mixed experience. We've used steppers, servos for our builds, for hobby, and for testing, and had quite a good journey. So yeah, it's quite a good topic, and let's get started on this. I'm just quickly looking here, some of the faces I can remember, and please, guys, I truly apologize if I miss any names. I have a very bad memory. I have a very selective memory, actually. So, but I can see Dave Gadden. Hey, Dave, how are you doing? He's always joining us from the States, so that's great. And as always, he's got a great channel. Please go out and watch Dave Gadden's CNC channel. He's got a lot of information, just like we guys do this show. He does a lot of shows, general talks, questions about CNCs. So yeah. All right. So I'll keep looking at the chat, and we'll get started on this topic because I think it'll pretty much take some time today for this. So Ben, let's first start with the what things should we first pick up, because there are quite a few differences on both the motors. Should we talk about the torque and the size first, or how do you set up? What do you say?
Maybe start with the way the difference in how the motors work. Do you think? What is the difference between a servo and a stepper? Let's start there.
Right.
And
right.
I don't actually know a lot about servos. I have used them, but I use steppers all day, every day, mainly due to the cost. Steppers are usually a cheaper solution. But I have used them and do know a little about them. And the difference, according to Ben, is that servo motors are sort of a PWM-driven motor that doesn't have a detent. So they're more like a standard motor that will spin around and around without having a locking step.
Right.
And
so it's basically just like any AC or DC motor, that you give it some power and it keeps on spinning.
Exactly.
Yep.
Yeah. So where a stepper motor will move a certain step and then stop there and try and hold that position, a servo motor is more like a motor that will just continue to run. And if you need to hold it in that position, then there's no holding torque like a stepper motor.
So you're basically switching it off on that position. Once you achieve that position, you're kind of switching off.
Sort of, yeah. But to hold that position, unlike a stepper that has some holding torque, the servo will monitor the position and then provide a feedback to maintain the position. So the servo will move to a position and then wait there. And if it has any force applied to it that tries to make it move off that position, it'll fight that force. And the stepper will move to that position and then spend all its energy trying to hold that position. That's the sort of main difference on how they work.
Right.
They have very different ways of driving them. So you won't find that you can use a servo driver to run a stepper or the other way around, because they are totally separate technologies. And there is a lot more going on generally in a servo motor, because they are required to have some feedback to operate the motor. So they'll have an encoder attached to them, and often that encoder is also providing a feedback to the CNC controller. But generally, always the encoder will be talking to the servo driver and helping it maintain space.
Yeah, I'm holding on over at that point, and that's a great point, because we had a few people asking in general before about saying, hey, my encoder, I have old machine, the encoder doesn't work, can I somehow not use it with an encoder? So that's a great point, that for any servo-based system, even if it's a DC servo or it's an AC servo, you will need an encoder feedback. The motors just can't work. As Ben said, that the system needs to know the exact position, and the only way to know that position is through the encoder. Whereas in the stepper, you can get away with it because you know how many steps you've gone. So basically you can break down those steps into angles, and you know how many angles you've turned. Right.
So the servos are generally smoother because they don't have the little detent, and they can move to any position. A stepper motor needs to move to a position and in its either to its next detent, or using micro stepping to a position between one of its two detents. Right. And when I say detent, if anyone's got a stepper motor or used one, you'll notice that when you spin the shaft of the motor, you feel it lock to the next position. It almost snaps into position. That's the detent. Most steppers will have 200 or 400 of these unique positions, and you either need to move the motor, you either move to the next position, or using micro stepping, you move part way to the next position. Whereas a servo really has an unlimited, an infinite number of positions, because there are no positions. And so driving a servo is often smoother, and you don't have some of the issues to do with micro stepping that you can come across with a stepper motor. Yep.
And so, and because the steppers, as you said, they're literally holding on to that position because you have the coil activated. And you guys can, if you really want to do some more research, and I think a lot of guys do have an idea how steppers work, but you can go on Wikipedia, and they've got really good details. But end of the day, it's a magnet and a coil. So the actual shaft, the rotor of the motor, is the magnet. And it's divided into those little steps. So, as Ben said, 200. So I think that that is 1.8 degrees or something. So you'll have those little steps, and then you'll have coils on the other side. So if you have one coil activated, it becomes a magnet, and there's a magnet in front of it. They lock up in position. And what I've seen, I've heard talking to a few people in a lot of really sensitive applications. People actually use stepper motors because then they are actually holding on to the position. And I've heard the same for someone was talking about a grinding application, because for grinding, the reaction when you're trying to grind something on a servo, it has to still react. But stepper, it's actually on that position. It's holding your tool or whatever you're grinding on that position. But I'm not still saying at the same time that steppers are the answer for everything. But it really depends. So, you have to understand, again, the differences of the design, how they actually hold the position, because holding the position is quite important from that design point of view. And a lot of people who are using, routers or even milling machines, lathes, it won't even make that much of a difference. We're going to talk about other things too, that, how you decide up which motor you're going to use. But, if it's sometimes you have an application where you really need to understand how system works so you can really fine tune the system. That's where having that knowledge about these motors really help.
Mm-hmm.
Right. Another big, so that's the basics, how the internals of the motor work. And now with this design difference, the basic mechanical or the electrical setup is so different of these two systems. That also results in size differences. For example, the servo will be a much smaller size, but still give you a much higher torque than a stepper motor. So is that correct, Ben?
Yeah, from what I understand, the same motor or frame size in a servo is usually a little bit higher torque, and I don't know if it's big enough for that to be a real decision maker. There's so many other important factors between the motors that might lead you to one or the other.
Yeah, but it's just like a comparison thing. So people know sometimes, people say, okay, I'm looking at a servo system, it says it's that many watts, and then I'm looking at a stepper system, and then it's that much Newton meter torque or something, and they're like, how do we decide? So every time you see a servo system, wattage is one thing, but also go into the data sheet and look at how much torque you've got, because that's where you can compare the both, and then say, okay, these are the two numbers I have, and then don't look at the size. That was my main reason, because the servo might look really small compared to a stepper, but it might have much more torque than that.
Yeah, and also, where are you looking for your torque? In a low rev range or a high rev range? That was my next topic. And that's,
exactly. Yeah. So maybe you want to carry it forward, so size was one thing, and next is definitely the torque. How do you decide, and where do you see the torque differences? Ben can take me through a bit more details, and maybe you can also give some information about different types of stepper motors. But just very quickly, if you're doing a comparison on the torque, so the stepper motors are really good at giving you good torque on really low RPMs. But the problem with the stepper motors is, as you increase the RPM, the torque literally dies. So if you're trying to run them on high RPM, you can hold the shaft by hand. It's just going to start missing steps and just start vibrating. It won't have pretty much any torque. So you have to be really keep that in mind. For a servo system, you can go from all the way from 1 RPM to the servos are generally 3,000, 5,000 RPM, and you can go the entire range with the exact same torque. Because they're getting the feedback from the encoder, they have electronics. We won't go into details, but that is a huge difference. So you can run a servo at 5,000 RPM or 100 RPM or 10 RPM with exactly the same torque profile. But
there are ways of driving a stepper motor to reduce this effect of losing torque or losing a lot of torque once you get up in the rev range. I don't know whether it's as good as having a servo, but the issue is with the steppers. When you're using a single step, which is moving at 1.8 degrees on a 200 step motor, you've got a lot of torque in that movement. When you start using micro stepping, and the higher the micro stepping rate that you go, the quicker that torque runs out as you start to build up your speed.
Right.
And so you've got to find a happy medium. If you set it on one step, then you get really rough, jerky movements at low speeds. And so while the motor is accelerating and coming up to speed, it sounds rough, it moves rough, and it's pretty horrible. So your single step modes are great up in a higher rev range, but pretty rubbish down at start and accelerating.
Right.
And so some drivers will have, so normally you have to pick a step mode that's good for starting right up to the rev range you're going to work in, and try and get as much torque through that whole range as you can. But one of the methods that I've seen for managing that is microstep morphing, which is where the drive will use a high stepping rate initially to help smoothly get the motor up to a good speed. And then once it reaches a predefined point, it'll switch back to single step mode. So you've got all that power available from the motor, even though you're up high in the rev range. Not all drivers do it. Actually, in fact, only a few.
Right.
But there is a way to get a stepper to.
That is pretty smart because, yeah, because when you're on a lower RPM, you know, the motor can deliver a lot of torque. Even if you have micro stepping on lower RPM, you'll still get the same torque. It's going to be much smoother. And once you move into the zone where the torque is going to be less, and then you go back and you decrease the micro step size to get the same torque. That's pretty neat. That's pretty neat. I haven't seen I haven't used anything like that. I remember you talking a few times, but I haven't tried anything like that. But that's interesting. That's
well, a lot of guys would be familiar with the Gecko drives. They're pretty well known and respected stepper. Most of those will morph from starting 10 microstep mode, and then at a certain rev range, they will automatically go to single step. And I don't even think it's an option you can turn off. It's just the way the drives work. So a lot of people are probably using the microstep morphing without knowing.
Without even knowing. Okay, so you don't have to like set up anything on that. It's just built in.
Just the way it works. Yeah.
Right.
So there's a couple. Gecko do it very well. I've seen a few other drivers that don't do it so well, but it's still useful. Yeah, there's a new exciting driver coming soon that I've heard, and might have the microstep morphing running on it as well. So yeah, that's one method of getting the full torque out of your stepper. Microstep morphing, Google it.
Great. Okay, so we've already discussed about how both the technologies, how different they are, why they're different, and we've talked about the size, the torque consideration. So again, and it'll probably make more sense when you guys are doing some research for your machines. You're looking at data sheet, and there are all sorts of numbers in that PDF. You'll see some graphs. They'll show you the RPM and the torque graph, and that's important. Once you see that, it'll make sense. If you see a servo one, it's going to be the same constant torque all the way. But if you see something for a stepper motor, it's going to start high. So at that point, your torque is high, but your RPM is low. And as your RPM increases, you'll see the torque just drops. And then you can see that difference, and you can work out your range. I don't know if someone needs to look into that detail, but if you need to down the track do some calculations, you can see, okay, at what RPM the torque is going to drop out, what's my ball screw pitch, and what kind of feed rate I need to get. If you really want to get into it, most likely you don't need to. Once you decide you're going to have a stepper or a servo, that's pretty much it. But otherwise, good to know. We're just trying to have this kind of a general talk today, so people know what's out there, and just in case they're doing some research, they can find out. Because I remember we were looking at all these torque graphs and things before, and we're like, what's this? It won't make any sense. But once we understood the concept, how these things work, and what's the reason behind it, looking at the graph would make the perfect sense. So that's where you guys can have a look. Another big difference is the feedback system. How you said, Ben, that for a servo to work, there is an encoder that's always watching your angle and what angle you've requested. So, if let's say you're on 0 degrees and a command came in from the controller and it wants to go on 90 degrees, for example, then the encoder is actually monitoring the shaft angle, giving the voltage to the motor, turning it until you reach that angle, and then stop. So another big benefit on this is it's a closed loop system. So basically, you give a command to the motor drive, it has to turn a certain angle. There is an encoder that confirms back to the drive that it's achieved it. In a stepper motor system, and we're going to talk about hybrids also, but at this stage, the normal ones that we use that do not have an encoder, basically the drive is blind. It's saying to the stepper motor, take that many steps, it'll make you achieve that 90 degrees, let's say. All right. You know, the drive is giving all those pulses, and if the motor is stuck, or maybe the pulse rate is too high, you know, the RPM is too high, it's losing steps, there's a load or something, there is no way for the stepper drive to know or notify the controller that, hey, I wasn't able to take the steps. So that's a huge difference. And
on top of that, there's also no way, even if it does reach the desired point, and then some external force moves it off that position.
Okay, so moves it back somewhere.
No way. Yeah, the servo will report back and say, "Hey, I was pushed. I'm off position." And you know, if the drive is reporting back to the controller, then the masser will say, "Oh, feed hold, something's wrong." Stepper motors, no such luck. If it gets to the position, great. If it doesn't get moved off that position, great. But really, nobody knows if that's true or not unless you're standing in front of the machine or you're close by and you hear something horribly wrong. That's the only indication you've got that the motor is in that position.
Sometimes, you know, we've seen it ourselves. You know, a cable from the stepper motor might come loose or something, and the stepper motor might not actually deliver the required step. Mechanically, it's all good, but electrically, there's an issue. So basically, there's no feedback system to the drive that knows that, okay, yeah, you know, we've achieved what we wanted to achieve. So that's also a big consideration, you know, when you're designing something. But at the same time, you know, then people might say, hey, then servo is the only way to go. But then we're going to talk about cost and other things later too. But again, you know, if it's a well-designed system, you have a motor that you know that it's not going to overload your system when you're doing a cut. Your cut size on your machine, for example, it's going to, you know, the deeper the cut you're doing, it's going to put more load on the motor, more chances of missing the steps. So you can even alarm out a servo system, you know, if you overload. So it's not purely about saying, hey, the stepper won't do the job.
That's right. If you size the motor appropriately, you've got all your gearing set up appropriately, you have appropriate acceleration rates that aren't going to leave the motor wanting for power to go and make that command. And then you operate the machine inside that design and don't push it too hard. There's no reason why a stepper, if it's appropriately chosen and used, isn't a perfect solution.
Exactly. So, you know, I don't want people to get this wrong impression saying that, you know, the stepper will never be accurate or something. You know, if it's within those limits, and every system has a limit, it's just you need to know, be aware of that, you know. And once you know, you're like, okay, you know, I won't push my system beyond that. It's a very stable system, and that actually takes us to maybe the next topic. That's, you know, the open and the closed loop. Is anything else you want to cover in that, or it's covered for the time being?
Yeah, that sounds good.
Yeah. So the next one that I was saying was, totally forgot actually. Sorry, what was I talking about? I started thinking about something else in the chat window. The open and the closed loop.
Well, we sort of covered open and closed loop. Most servos are closed to some degree, or all servos are closed to some degree. Whether that is actually fed back to the controller in the form of an error signal, or even in the form of an actual position. But that's not to say that steppers can't be semi-closed too.
Because they don't know, anyways. Yeah, they don't have that information themselves, kind of thing. That
some steppers have an encoder on them.
That's actually down the track. That's where, you know, we want to talk about the hybrid steppers also, or maybe actually we should cover it right now because it's kind of the closed loop system topic. Yeah, no, good point.
There's two names or two technologies that the hybrid stepper motors. Some people will refer to them as a stepper motor that's more like a servo because it has some kind of position knowledge, but really a hybrid, a lot of other people use the term hybrid stepper motor just to describe the technology in the stepper, whether it's permanent magnet or permanent resistance or permanent reluctance. There's two different actual technologies in a stepper motor, and most new stepper motors that you get these days are hybrid stepper motors because they are combination of those two stepper motor technologies.
And I've even seen people writing on their website, you know, not actually any kind of good brands, the stuff that you can buy on eBay, Alibaba kind of thing. They also put AC stepper motors, and they have all these different names that they put in, and people say, okay, I saw a hybrid, I saw a normal stepper, an AC servo, AC stepper, blah blah blah. So end of the day, basically, we have, I would say, three things. One is a servo system. It's a pure servo motor. And when we say a servo motor, it's either an AC or a DC motor. Then we have a stepper motor. All right. And the third one that Ben is saying about the whole hybrid thing, and it's just how someone names it. But basically, it's a stepper motor. So it does not have any electronics of a servo motor. But what they do is that they actually attach a little encoder at the back of the stepper motor. And then they call this fancy names, hybrids and all that.
You'll still see hybrid stepper motors with no encoder. A hybrid stepper motor,
right? Even
really,
if that's okay, it's even more confusing.
Motor. Just call a hybrid stepper motor a stepper motor. Inside the technology is hybrid, but it is just a stepper. What you'll see is hybrid steppers with encoders attached.
I was going to say that exactly. So we should have the third name, a stepper motor with an encoder on it. Yeah, exactly. So if you find any of these motors online that has an encoder, so what they've done is, and it's quite clever. It's nothing as too new. It's quite a simple idea, but it's a good idea in that sense, that they actually attach a little encoder, and the encoder feedback is tied back to the stepper drive. So what's happening is, when you get a signal from the controller saying that you want to move a certain degrees or revolutions, the stepper motor works in the same way. The drive says, okay, move, I'm giving you that many pulses, move 90 degrees or whatever. But the encoder is also keeping an eye that did the actual shaft of the motor moved that 90 degrees. If it did not move, it's going to try to move it to that for a few milliseconds. I don't know how those settings work, but it's going to try to do it for a while. If it can do it within that time, then it's good. Otherwise, it says, okay, I was given a command to go 90 degrees. I was not able to go 90, or maybe, as Ben said, there was some load or torque on the axis, and by the time it tried to stop, it can overshoot, and then it might go to 92 degrees, and because of the loading, couldn't come back. So the drive is going to disable itself and send an alarm signal that you can wire back to the controller. So in case of Meso, you have these inputs for each X, Y, Z, A, B drive alarm inputs. And then you can individually, from every axis drive, have an alarm tied up to the Meso. What's going to happen is, I actually had a client who, and I'll just give an example here, about having a stepper motor with encoder, but not using the alarm option. Basically, he was running a lathe, and his X-axis got overloaded, and the drive missed the steps. It found that it's missed the steps, but the alarm wasn't connected back to the Meso. So the X drive stopped working. But from Meso's point of view, it said, okay, everything's fine. It just kept on running the machine, and the Z-axis just kept on pushing into the chuck, and he ended up damaging a lot of things. So, and when he emailed me, and he's like, you know what, I should have listened to you, because I remember I said, hey, you've got great motors, connect the alarm inputs. And he said 10 minutes time, and I've wasted so many days now. So basically what I'm saying is that once those alarm signals are connected back to the controller, if any drive has an issue, it can be overloading, steps missing, over temperature, or any kind of an issue, it tells the controller that, okay, there is an issue with this drive, and then the controller actually stops everything, puts the system in feed hold, stops your spindle, and then on the screen shows this alarm message saying that, hey, your X-axis drive has an alarm. And that way, as soon as the drive stops working, or the motor stops working, or it misses a step, the whole machine stops and tells you before it starts damaging something else. So that's really an important point. So if you have a feedback system, now the same system is available on the servo. That's actually the main concept or the basics of this whole setup. So even with the servo, it's the same thing. If it can't reach that angle, or there's an issue, it's stuck somewhere, it's going to give an alarm to the control, it stops. So basically, keep in mind that's where the closed loop and the open loop will have a difference. The open loop, you won't know what's happened. You won't know you've lost steps, and you can't react. You can't stop the machine until it's gone to a point where you can visually see it, and you're like, oh wow, something's wrong here. So keep that in mind. And I personally think if you're going to use a stepper system and you're concerned about the feedback, I don't think these closed loop stepper motors with encoders are that expensive. And I think it's a very good idea to use them, because when also you're fine-tuning your machine, let's say on a normal stepper system, with experience, you know how much acceleration or full feed rate it can take. It's kind of at times a guess. But if you have a closed loop system with an encoder, when you're putting those values in and you're trying to move your axis, and if you can keep on working on those numbers, increase those numbers until actually you hit an alarm state. And because at that state, the drive is going to say, okay, I couldn't handle that much speed or acceleration. That might also help you tune the system.
And then you obviously have to take a step back from there, because you may not have the machine as loaded up as it will ever be. But yeah, at least it gives you the ability to get an idea of what it's capable of.
Yeah, or maybe like, initially you think, as you're saying, without any load, it's running good, and you're like, oh, I'm happy, and then you start cutting, and then you get a bit of loading on the tool or the axis, and then the alarm comes on the drive, and then you can say, oh, okay, maybe I just need to reduce my settings. So it's at least the system is telling you that I couldn't do what you said. It's an overload situation for me. So that's a big point for comparing both the different type of motors.
Jatinder, I apologize. I need 5 seconds. I'll have to disappear on you for a moment.
Not a problem, not a problem. So I'll try to pick up a topic that I can talk on. All right. So while Ben's gone, I'll just quickly go through the chat. If someone can let me know how many people are watching, that'll be great. Sorry, I have too many windows open on my screen. So I think that was, made it clear about the stepper motors, the servo motors, and the steppers with encoders. Wow, okay. Great.
Sorry about that.
That was quick. No worries. I was still trying to find what I'm going to talk about. So,
well, I wanted to make one more comment on that last topic, just to say that, so by adding a encoder to a stepper, you can, get some of that usefulness that you might have had by using a servo motor. You're still left with some of the drive considerations, like the micro step issues, stepping rates, etc. But it is bringing it one step closer to having a full servo system without the extra cost. So, that it can be a good option if you're only looking at servos for the closed loop. Then you could probably spend half as much and have some steppers with the encoder.
Yeah, because and again, actually, let's talk about the RPMs. Actually, that's becomes really important, and it connects to what you just said. As we mentioned, that RPM is also a big consideration. Excuse me. So on a servo system, you can get a good RPM from up to 3,000 to 5,000. On a stepper motor, if I can remember correctly, I think I was able to get about maybe 1,100 RPM with good torque. I don't know what's your experience been with this. Did you have any numbers for steppers, like any RPMs? But okay, yeah, it's considerably low. You can't go anywhere near a servo system. So that brings to the next question: is that on your machine setup, one might say, okay, I'm going to just put a servo system because they're just great. I have all this torque, I have all this RPM, and I have closed loop. I'm going to just put that. But still, at that time, on the mechanics side of things, what are you cutting? Because a lot of time when you're cutting at a very low feed rate. With the higher RPM on the motor means the higher RPM you're going to get on your axis movement and your feed rates. Now, if it's a machine that's quite big, you're running a production job, and you have to move from one point to another point fairly quickly to save time, I won't have a stepper system, and especially if the distance is quite far, because the stepper is going to go real slow, go there. It's still good speed. Not saying it's like going to be really slow, but compared to a servo, it's going to be slower.
I can rapid my machine at 60 meters a minute with a stepper. So
Right.
it's not, depends how it's set up and geared. Yeah.
Yeah, exactly. Like, you know, what sort of ball screws you have, the pitch, you know, it's going to end up, because it's just not the RPM on the shaft. It's how it actually gets transferred to the machine, you know. Sometimes people have pulleys and ratios. But yeah, comparing the RPM, the main thing is that you have to keep in mind is that if you're traveling a lot of distances and you need to do it fairly quickly, that's where it's good to have a servo system. But if you have a machine that, you know, you don't need that much feed rate, because when you're cutting, you don't need that much feed rate anyways, you know. You cut fairly slowly if it's not a laser system or anything. And if you're just moving distances that are not that long, then stepper will do, you know. But that's what you have to keep in mind, you know. If someone has I have a client, he's got a lathe and he turns quite a long job. So his x-axis actually does not have that much movement, but it's quite long piece that he has to face, come back, and then face again, kind of thing. So what he did is that, and he was talking to me, he's like, what should I put in for what axis? And you know, money is always a consideration, and complexity and all that. So we actually said, hey, why don't you put a stepper motor on the x-axis and a servo on your z-axis? Because you can do that. And there is no limitation. It can be any combination, because sometimes people ask me, they're like, you know, should it be all servos or steppers? No, use a combination. Like this is a great example. Like X, he just needed a very little movement, but for the Z, he had to travel quite a lot. So, you know, he just put in that great combination, worked out well. So also keep the RPM consideration in mind when you're choosing a system.
And on the money topic, sometimes it can be cheaper in the long run to spend up front and get a fully closed loop system. You know, when you're considering setting up a machine, what type of work you'll be doing, whether it's in a production environment, are probably important things to consider as well. Because if you were going to set up a CNC machine to do volume production, run all day, semi-attended, you know, you might want to be in the next room or just a few meters away doing some work, and you'll have the CNC machine hammering away all day, knocking out a particular part. In that instance, having a machine that will either do the job guaranteed or stop if it can't might save you money in tooling and loss of stock quite quickly.
Very true.
If you've upfront bought the servos. Whereas if you're not going to run the machine terribly hard, like right on the edge of its ability, and you're not going to be leaving it unattended or semi-unattended, or you're working with wood or some cheap stock and end mills, or it's just a hobby machine, then, you know, that might push you straight towards the stepper motors. Yeah.
That's a good point, and actually that's why we're having this topic kind of quite wide today. Is that there's no set way, honestly. You know, there's no set way. Every person has a different need. The machine is different. The job they're doing is different. The kind of job or how many they're doing. You know, they're doing one piece a day. They're doing 100 pieces a day. It's a combination, and that's what, you know, we're trying to put in all this information and telling people that there is no set way. Just having that knowledge that all these things will have a difference, and then I think, you know, the person who's designing the machine or using it is the best person to decide in their own situation. Like, you know, what you just said about production. Ben, I have a classic example. One of my clients, he made a little turning center, a lathe, a very small one, because he makes little parts, you know, this size, some pins for tractor parts. And I always give his example. He's running a stepper system without encoders, all right? And he is making 1,200 parts a day, 7 days a week on that system.
So he's done a good job of selecting the right stepper.
He's got a really
setting up the job to work within its ability.
I've seen his motors, and when I saw the machine and the motors are at least twice the size what he needs. But I think that's what has saved him a lot of trouble. To what you said, that, you know, it's just as a backup, it's got more than enough torque that it won't miss any step. until unless there's something going really bad. So, so in that case, because he's just moving a little distance, machining and then coming back and to load that part, because you have to time it, 1,200 parts a day, all right? You have to time the machining time, and then someone has to change that part, all right? So it has to be done fairly quickly. But classic example, if the distance isn't that much, a stepper is good enough, all right? So that's what I'm saying. So someone might say, hey, I need production. I'm making this much bit of part, and I'm going to put a servo. You might not even need it. So, it's good to have that knowledge, because when you go out there, it's more like you're shopping for a motor, and everyone's going to sell you what they make. And at the end of the day, you'll have something that's probably an overkill, or it just doesn't do the job. So that's great.
There's no reason why you can't move from one to the other. We've got a topic here of the frame sizes, and they are often the same. You will often find the same bolt pattern for a stepper and a servo. And if you want to start with a stepper just to get you up and running cheaply, and move on later on down the track when the funds are available to a servo system, great.
Yeah.
You'll find something to do with the
one
steppers.
One of the things, to keep in mind is the size of the motor shaft. Servos will have much bigger diameters. I've had a bad experience myself. I designed something, didn't leave a room for it, and upgraded to a servo system, and my coupling became so big it wouldn't fit into the whole mounts. So just keep that in mind, when you're doing that research. It's generally, like I've seen, it's quite big, more than double sometimes the diameter of a stepper. Yeah. So maybe the reason has been, as we said initially, because of the size of a stepper and the servo and the torque. So even if it's the same frame size, it's got more torque, and that's why the shaft is much bigger.
Right.
So that can be the case.
Okay, that makes sense.
Yeah. All right. I was saying that we are. I think we're going to run out of time. Just 15 minutes left.
Wow.
Let's go for the topics first that are more important, just in case we run out of time. We can probably drag along another 15 minutes longer program today. Did you want to talk about wires, Ben? Steppers come in different wires, 4, 6, 8. I do get confused, and I'm 100% sure people do get confused. They're like, hey, what's different? Which one should I choose? And also, first of all, the difference, and then how do you choose the drive for it, for example?
Okay, so steppers commonly, most steppers you come across have got 4 wires, and they're the easiest to deal with. So you do find 5-wire, 6-wire, and 8-wire steppers, and most of them can be wired as a standard 4-wire stepper. So if you have you have to choose a driver capable of running the stepper, and most drivers we're finding nowadays are simple 4-wire drivers. So it's not to say that you can't use a 6 or 8-wire motor if you come across one, because those extra wires can be configured in a way to let it run like a standard 4-wire motor if need be. So a 4-wire motor will just have 2 coils, 4 wires coming out of them. Very easy to understand which wires are which. If you just join any 2 wires and find that the stepper won't move, then you've found a pair, and your stepper driver will have 2 pairs of screw-down terminals. Plug it in, away you go. These are usually bipolar motors. So there's 2 types of stepper: the unipolar and the bipolar. Bipolar steppers need a bipolar driver, and they are the H-bridge style drivers, where you're using the entire coil, and the H-bridge in the driver is just switching the direction of that it's charging the coils to make the motor go in one direction or another. So they have full torque in either direction, and it's really the usual way now to drive a stepper is to use a bipolar motor on a 4-wire driver. So the other motors that are the 5, 6, and 8-wire motors are usually unipolar, and depending how you drive them, they may use half the coil for one direction and half the power of the motor and half of the coils in the motor to drive in one particular direction and half to drive in the other. Or you can wire them back to a bipolar setup so that you are using its full coil and power in both directions. I always have to go and look it up when I go to wire up a 5, 6 or 8 motor back to a 4-wire system. It's pretty clear and easy to identify the 6-wire systems because they are, whereas the bipolar motor is 2 sets of coils, there's just 2 sets of 3 with each coil having a center tap. And the way the unipolar driver will run it, it'll charge this side to go forwards and this side to go in reverse. So with this motor, excuse me, it's hard with my fingers to show, but you can basically ignore this. Just pretend it's a 4-wire motor. You find that
one full coil. Exactly,
yeah. If you can find the 3 wires that all have some form of continuity, and then measure the resistance across them all, one of those wires will have a smaller resistance to the other 2, and you just ignore that wire. It's a 4-wire motor. And
so one of the questions is, why do there are so many different types? What difference does it make when choosing one? You know, it gets confusing.
Well, it does get confusing, which is why I just use 4-wire motors.
Right. And I've seen most of the drives that you see online, they have output for 4 wires, most of them.
Yeah, it's the most common now, and unless you have been handed a 6 or an 8-wire motor, you won't have to worry about it. If you go to buy a stepper motor, just buy a 4-wire motor. And if you can't find the exact motor you're looking for in a 4-wire version, just know that the 6 and 8-wire motors can be wired to use a 4-wire system. It's if you Google wiring an 8-wire motor, you'll come across a lot of people showing you exactly how to do it. Actually, I've got to say the 8-wire motors are really quite versatile because they have 4 sets of coils in them, and you can either wire them up. The 2 sets of coils on one side, for example, you can wire them in series, like I can't make the sign with my fingers, but bring these 2 together and treat it as a 6-wire motor, which means ignore this, and it's now a 4-wire motor.
Access to the all coils, and you can just do any combination.
But you can also run those in parallel, so that it's more like that. This finger thing is not working. But I think you can look at increasing torque or increasing torque at RPM by wiring the motor in a different fashion, and so it is quite versatile having an 8-wire motor because you get the opportunity to change the way the motor works without going and buying a new motor.
But I would say, From if I'm building a machine or something, it's just too confusing. I would just go out and buy a 4-wire one and just use it. It won't even make any difference, that much difference to me.
Absolutely. It really is. If you've got motors out of something or someone gives you some motors and they are 5, 6, 8 wires, generally, although not always, as just pointed out by someone in the chat there,
right? Generally,
you can work out how to run them as a 4-wire motor. And if someone hasn't given you one, don't go and find one. Buy a 4-wire motor. It'll make life a lot simpler.
Right.
Especially with the 8 wires, there can be a lot of fiddling with a multimeter trying to work out what is what.
Yep. So for these 4-wire motors or whatever, generally you can buy any drive, the geckos or any drives, around that, whatever they support, and use it. Just one point I want to mention here is that how we discussed about having the stepper motors having those encoders at the back. In that case, generally they come in pairs of like a drive and a motor, like a complete set. Sorry. So do keep in mind that if you see a motor somewhere and you say, "Oh, okay, I'm going to buy this motor," and that has an encoder, and I'll use some other drive, generally it's not a good idea. So always make sure you buy the motor and the drive from the same manufacturer, because most likely it won't work on a different system. If it's just a normal stepper motor without an encoder, it will work with most of the drive.
I haven't come across any combinations of standard steppers and drivers that don't really work together. Yeah, of course, once you throw an encoder in the mix, it's got to be,
the manufacturer's drive,
but it's best if it's,
exactly. And the same is with the servo motors. We actually had a lot of questions. People are like, oh, I have this old servo motor, let's say Panasonic, and can I put a Fuji drive on it or something? Most of the time, no. You know, it just won't work. It has to be a matching drive. So do keep that in mind too. Great.
So we are running low on time. We should have a look at which one of these topics are important.
Noise. Let's talk about noise. Yeah.
Audible or electronic noise, EMF noise?
Let's talk audible first, and then we'll go EMF.
Okay. Well, steppers, if anyone's got experience with them, you know they can be horribly noisy. It's often a lot more to do with the drive than the stepper. But they often hiss and whine and hum, and especially when they're sitting stationary. So yeah, approaching a CNC machine, you can often tell if it's powered up as you walk over what its technology is, because of that hiss and hum.
Right. Okay. And also, when when the motors are working, servos are generally very quiet, because, as you said,
Not
there's
doing
no step.
much. Yeah. Well,
even on high RPMs, you know, like, because on the frame, let's say when you have a motor on the frame and you're running a stepper, it depends on what RPM. You know, different RPMs going to have a different audible frequency that's going to resonate into the frame. But steppers, because they're taking those little steps, it's going to be like jerky or like noisy kind of thing. On a servo, it's smooth. I remember we converted one of our lathes from a stepper to a servo, and we initially thought the coupling is slipping or something. We couldn't hear anything. You know, it was so quiet. So
yeah, well, it's not lining up lots of little jerks to make a movement. It is a smooth movement. So yeah, that is a consideration on steppers. They have resonant frequencies and other positions on their rev range where they do sometimes cause trouble because of that vibration in movement that you don't have with a servo.
No, we have a client in Brisbane who bought an old big router machine, and all of a sudden the controls died on it, and he said he's going to put a master, but the drives was they didn't had any standard step and direction signal, so they couldn't connect to any new controller of the Meso. So he said, okay, I have some stepper motors, I'm going to just put those on. And he's like, it's reliable as his servo system. He's happy, everything's fine. The only thing he complained, he's like, okay, the servos were much quieter. When the spindle, obviously the spindle noise wasn't there. But you know, like, that's one of the things he mentioned. You know, it's not a big thing, but they do make that bit of a noise. But once you have a spindle running or you're cutting something, it's not that much anyways. Cool.
We just got an interesting question here actually from KVID. How do you calculate maximum voltage for a stepper?
Right.
And it's a question I've had quite a few times, because when you buy a stepper, it'll say 3 amps at 5 volts or 3 amps at 3 volts or whatever it is. And obviously we're not going to run 3-volt systems for the stepper. So the way that works is the manufacturer will pick a nominal voltage of 5 volts or 3 volts, and they'll give you a current rating for draw at that voltage. But they never actually expect you to run it at that voltage. There isn't really, well, actually I'm sure there is, but you could say there almost isn't really a maximum voltage for a stepper. What you have to, your stepper driver is managing current, not voltage. So the maximum voltage for your stepper is usually the maximum voltage the driver can handle. So, for example, a really common one, the Gecko G540 can handle 50 volts, absolute maximum. So you can drive it at 48 or at 24 or at 12.
And that's why, like, you know, it's good to anyways run them on high voltages, because if you look at the wires anyways on the motors, they're not thick, you know, they're not meant for current. It's mainly voltage, because end of the day you're pushing the same wattage.
That's true. That's true. And also higher voltages are in the step system. You get more power at higher revs. So if you're running at 12 volts and you're trying to really spin the motor up fast, you'll find stalling issues that you won't get at 24 or 48 volts. So the answer to maximum voltage for a stepper, hit it with as much voltage as your stepper driver will accept. Obviously, if it says 50, you won't find a 50-volt power supply. Go down to 48, make sure it's regulated so it's not going to have spikes over 50, and that's how you choose your voltage.
Yep. And, you know, John mentioned here in the chat that, you know, he's recently changed to 16 micro stepping on his drive, and it's much quieter. And exactly the same thing. Exactly, because those steps now have been divided up into 16 more steps, and, you know, they've become smaller. The jerk's going to be much smaller, and obviously the noise is going to be much smaller because it's more like little steps, and it's at a higher frequency. So yeah, no, that's
to see that amplified. Switch back to single step and see how horrible it is.
Yes, especially at low RPMs where it's just like you know, kind of struggling. Yep, no, great. So good one on that.
That actually leads us into another topic we had here: AC or DC voltage for your step drive system. We were talking about their maximum voltage to run. And the fact that it's current limited. We're providing watts, and it's very easy to do on an AC system because it's just whatever, you know, you're just supplying it 240 volts or 110 in the States. The reason why I like the idea, I don't have any and I haven't used any, but I've seen stepper and servo drives that will accept AC mains power. And I really
because they have a little power supply built in to the system,
or they're just sorry, one moment. Yeah, so they've got a rectifier and some associated electronics built in. The reason I like it is because DC power supplies are expensive, really expensive. I mean, you can get eBay power supplies and Chinese power supplies for a couple of $100, but if you went in Australia, I'm not sure about the States, but in Australia, if you went to buy a 600-watt, 48-volt power supply from, you know, that's been imported and approved and is legal to use, you're probably looking at $800 for a power supply. $600, $800 for a power supply, and that's probably, if you're using steppers anyway, worth more than all the steppers and drivers in your system. So, depending how much power you need. Don't just consider the cost of a stepper motor and driver, or a servo and driver. Have a look at what's going to be the cost of the power supplies that I need to run in order to run these drivers, and you may find that having a 110 or 240 volt system will actually save you money.
Yeah, it's because another thing is it's a matching system, because, you know, they've already done the numbers that how much load it's going to take, and then also, if you have 3 drives, basically you have 3 separate power supplies, you know, so they're different loading, only one will fail, not everything will fail. I personally prefer that too. I think the question Paul had was that, you know, about regulated and unregulated. I had a similar experience, actually on the same client who's running that production job on the lathe, because these servo drives say that you can feed in AC and DC voltage. And initially, in their case, they had a transformer. They didn't put any rectifiers or caps on it, and they just fed the AC 80 volts or something, because their drives were rated at 80 volts or something. They were huge drives and motors, and they had all sorts of issues, man, all sorts of nightmare. And then we realized is that if ever, like any of you guys have ever opened these drives, you look inside those drives, they've got little rectifiers and little caps. They're really tiny and not good quality. So, you know, inside, if they're trying to convert that AC into DC, they're not doing a good job. And then you're not getting the right DC current. You need to have good caps, because that's where you're going to hold the charge when you need to, all of a sudden need that torque or that high RPM that you need to push to the motor. What we've seen, and I tell everyone, I do not believe those drives. Always feed them nice DC voltage. If it's a power supply, then it is DC. If it's a transformer, have a good diode bridge and good caps. Maybe a bit of an overkill. Put a bigger cap so you can have enough charge, and you supply nice and neat DC voltage to your stepper drive.
Mm-hmm. And some of the unregulated supplies, like the big chunky, what do you call them? Transformer-based supplies over the switch mode style, they can actually provide a lot more current instantly than the switch mode power supply. So a lot of people will be using the big coil and rectifier. The issue I have with them is that not being regulated, you probably need to run a slightly lower voltage overall so that you're not sitting right on the edge of your driver's acceptable input, because they don't have a voltage regulation. But otherwise, I have seen issues. I know that Gecko, but they recommend using one of the transformer rectifier pairs rather than a switch mode power supply. Yeah, I've gotten away with using switch mode the whole time and not had an issue.
Yeah, right. Ben, if you don't mind, because the time is up and I think we're going pretty good, it will be good if you can cover the rest of the topics. Do you mind doing another 15-20 minutes on the show?
Yeah, I'm fine.
Great. We did a bit of a talk on the actual noise, the audible noise, and we need to talk about the electrical noise. And someone actually asked the question in the chat about having a shielded cable for the stepper motor. So maybe you can cover both the topics together about steppers and servos, electrical noise, and then about the cabling.
Right. Okay. So I actually don't know a lot about the electrical noise. I understand that there will be some EMF from driving the motors, but a lot of it's generated or suppressed on the control card. So every system will be different. It's not just because you're driving a stepper, there'll be noise.
The way we've seen that is pretty much every stepper and servo system that we've used, pretty much no issues. Only the VFDs that are making a lot of noise, and we've already talked about that earlier. So these two systems haven't seen any issues, but just one client in particular who was using some Chinese brand servos. They were making so much electrical noise that the system was running on its own, kind of thing,
And I've actually seen some Chinese servo drivers so noisy that VGA signals in the same region were just getting destroyed
into their own system. So basically, the client had these 3 servos, no controller connected. All right, and there was so much electrical noise that the machine was just running on its own. They were just
generating its own step and direction pulses.
Yeah, exactly. So it was going crazy. So in general, if it's a good one, it's a good brand. We've never seen any issue. But yeah, because you go online and you'll find everyone making servos now. All right, and that's the problem. So at that stage, the signals, the noise is so bad anyways that you can't fix it. There's no point. But otherwise, if it's a good system, hardly any electrical noise issues.
Yeah, and I've gotten away with always using unshielded cable. I still don't have a machine that I've set up using shielded cable. If I use shielding, it's often in other lines like limit switch lines, etc. And it's not usually a result of the noise, like you said, being generated from the step motors or the servos. It's usually VFD noise or other noises, saws in the next room, sump pumps, fluorescent lighting, starters. Those are the sort of things that are generating noise and ruining ruining jobs in my experience.
Filters and all that. Yeah. And in fact, we should do some maybe a podcast about filters. We're still in the middle of doing some research for a client who had noise issues. So actually, once we have some good information on that, I think it's really important because, yeah, some of the issues he's been having, they were quite random. But yeah, that's off the topic. But on the shielding topic, there are actually two sides to shielding also. Like one is actually from the drive to the motor coil. And there is another shielding question that is from the actual controller signals to the drive. That's kind of more important. If the distance is quite large, I don't know how many meters, but we've tried, 2-3 meters. So the drive is sitting maybe 3 meters away from the controller, and it's not shielded. Still no noise issues. Sometimes people think, if it's not shielded, you're going to get those noise issues. But what we've seen, and it's pure experience, and if someone has a different experience, please do share. But what we've seen is that because the drives have optocouplers and their own filtration circuit, and most of the time we are sending differential signals from the master outputs, you don't need shielding. We've hardly seen like any difference, So yeah, if it's like your system is making a lot of noise in those cables, let's say from the drive to the motor, and that electrical noise is getting into the system, maybe you need to shield it so it doesn't get transmitted to other things.
I would say if you've got drives making that much noise, swap the drives out. Yeah,
exactly. Because a normal system shouldn't give you problem. Yeah. All right. Cool. So that's done. Ease of wiring. That's another one we should quickly cover. With the stepper or a servo system, generally, most of the servo systems actually have the power supply built into the drive itself, so you don't have to wire from that. But there are a few, like the DMM Tech Canada. They have 1 series, DYN 4 series. They have the drive built in, and you can hook into 110, 240. But they have DYN 2 series where the drives are really small, and you need to give it a DC power supply. So that's where you might have another power supply. You need to run cables to the drive. You have to keep in mind about that. The ClearPath motors from US, they have the drive built into the motor. That's kind of neat because you don't have to run any extra cables from the drive to the motor. But the problem is then you still need to have a power supply. So power supply is pretty much just like having the drive somewhere else. So end of the day, from cabling point of view, it becomes it's the same issues, If we do a comparison between a servo and a stepper, if it's a normal stepper without an encoder, you're just running the coils, the wires to the coils from the drive, step interaction from the drive to the masso, that's same. For a servo or for a stepper system that's got an encoder, the only difference is they're going to be another set of cables coming from the encoder to the back of the drive. It won't make that huge difference, honestly. If it's,
I would expect they would be shielded too.
They are, especially the encoder ones. Yes. The only thing to keep in mind with those encoder cables, the experience I had, sometimes the cables and the connectors, especially cables you can get from anywhere, the connectors are so kind of specialized. You have to get like those special connectors from the manufacturers, or try to get the cable. Maybe when you order the motor, you need to see how long you need the cable for the encoder. So you order it. For a stepper motor system where there's no encoder, you just solder a few cables and you're good to go. So keep those things in mind, that you might need special cables when there's encoders involved. With the stepper motors I've seen, they generally use those DB connectors, DB9s or whatever. So they're still fairly easy to extend. But for servo systems, you will kind of need some special cable or connector. Do you have anything on the cabling side, Ben?
No, not really, other than when you're considering cables for a stepper, that the other thing, other than shielded and unshielded, to think about is voltage drop. So if you're going to have long cables, they may need to be thicker. then the cables coming out of the end of a stepper motor are usually 100, 200 mils long, and they might look like a 20, 16, 18, whatever gauge cable. You quite often have to use something a bit heavier than that for your run back to the driver, because if it is over a distance, you could be looking at some significant voltage drop, and running nice warm stepper motor wires, which you don't want to do. So that's probably more of a consideration than do I use shielded or not, is am I even using the right cable? We spoke about stranded versus solid core cable when we were talking about the VFD topic, and that applies obviously as well to every wire that's running through your drag chains. That they all ought to be able to handle constant rolling strain over whatever the bend radius is of your drag chain.
Radius of the chain, yep.
Yeah, so you've got to think about that when you're doing your stepper motor and your signaling wiring as well. Think about current carrying capacity of the wire and potential for voltage drop. You can get calculators online that you give it the size of the cable you're using, the current draw, etc., and they'll give you an indication to the voltage drop. But yeah, something to consider when you're setting up your wiring. Yeah,
and one thing I just remembered, and we kind of forgot to talk about it. Also, when you have a stepper or a servo system, just like with any other system, as you add more stuff to it, it gets more complex, and there are more things to go wrong. With the normal stepper system, where you don't have an encoder, such a simple system that there's hardly anything that can go wrong.
Yeah.
With the servo system, you have an encoder. There can be electrical noise going into the encoder getting damaged. Maybe water going into the encoder, things like those. So I've seen a lot of even industrial machines failing because something happened to the encoder. Because if something's wrong with the encoder, the drive is going to give it an alarm. The machine's going to stop. So initially you might think, hey, is it something stuck on my machine? Why is it giving an alarm? The next thing is your encoder is dead, or the signals aren't coming, or they're too noisy. So those are some of the things that you also need to keep in mind when choosing a system. But most of the people, I don't think they even need those servo motors. I've used them. I really like them, but it really depends. So that's what we've been trying to cover in today's show. I think we were kind of able to give you the broader picture of what's out there, what are the different options, and select for yourself kind of thing. And if you've missed something, you need, you have more questions, need more.
There was one more thing that we were going to mention was braked motors.
Sorry, which ones?
Braked motors.
Yes, brakes. Okay, yep. All right. So, do you want to talk about it?
Oh yeah. There are steppers, and I assume servos, haven't gone looking for them, that have a normally on brake sitting on top of them. So when you see a stepper or a servo, you have an encoder on the end. There's another attachment that can go after that, which is a brake that is normally on. So the idea is that when you power up your machine, as the motor receives power, it releases the brake. And this is really convenient when you have a machine. If you had say a flatbed router that you'd stood sideways up against a wall to save space in your workshop, or you had a particularly heavy spindle running on your Z-axis.
With a ball screw.
With a ball screw, very little resistance. Turn the power to your machine off, and if the spindle's heavy enough, it'll just down and smash whatever anvil you've got into the base of the machine. Yeah. So the idea of using a braked motor on your Z-axis can really be handy to so that in the event of a power failure, which happens every time you turn your machine off, by the way, the brake will kick in and stop your motor from moving. There was one other type of motor or motor attachment we hadn't discussed.
Yep.
They're not expensive, and they're really, really simple. You don't have to configure them. You don't have to run relay outputs from the Masso. Just when your 24 volt or whatever power supply comes online and feeds motor to the brake, it releases.
Yeah, but actually, I've seen this with the servo. I haven't used it on a stepper system. I've used it on a servo system. The signal for the brake to release actually comes from the drive itself, because the drives also have caps. So even if you lose power and if the timing isn't right, so if you put the brake before the caps died on the drive is still trying to run it. So that's why the drives actually control the brake themselves.
Right. Okay. Yeah.
So that's also something that you guys need to keep in mind, because not a lot of people use these on Z-axis. There are counterweights and other ways to do it. So if you're looking into brakes, do some research. But
yeah,
generally,
and if you're buying a bigger spindle, a customer of mine recently bought a 5.5 kilowatt auto tool change spindle. When it arrived, we got a shock. It was like a little rocket. It weighs 24, 25 kilos. And we realized straight away this is going to be a problem. So if you're going to a ball screw on your Z, or you're buying a bigger spindle, heavier spindle, then that might be a consideration. Does my servo or stepper need upgrading to a braked version?
Yeah, and also check with your drive that does it support the brake signal, because if it does not have it, you're going to have issues. So you need to confirm that the drive can give the brake signal.
If you're using a servo.
Yes, I haven't used on stepper, don't know. Yeah.
The stepper is really simple, really. When the machine gets power, it releases the brake. So you've got your 4 wires going off to your stepper. You just send another 2 from the power supply. Whenever there's power available, it turns the brake off. So stepper, it's easy. Servo, yeah, you've got to do that.
Might be more complex. Right, yeah. That reminded me of another question. Now I remember what I was going to ask like 30 minutes ago. Like stepper motors, I've seen online, people actually use stepper motors to make little wind turbines and make electricity, because it's a small generator. End of the day, you turn the shaft and you can get voltage out. If you have a machine switched off, but it's still connected to your drives, and you try to move the axis and you're spinning the motor, can you actually damage your drives?
I don't know. I mean, I believe you probably could. I do it all the time. If you move the carriage slowly when the machine's turned off, you're okay. But if you move the carriage enough to generate enough power that it actually supplies the logic side of your driver with its 3 or 5 volts, whatever it is, then the driver fires up and goes into clamp mode. So you're pushing the carriage. When you get to a certain speed, bang, it locks up. And I do it over and over and over again. I haven't destroyed the current machine I'm using is running the Geckos. I've got to say they're pretty resilient because I do it a lot.
Right. Okay. But sometimes, as a troubleshooting, someone might damage something. They're like, hey, why did it got damaged? So keep in mind, maybe a different brand or something that might make a difference. And,
Yeah, I say don't do it. If you're going to move the machine while it's powered down, just do it slowly so that you're not generating huge amounts of power and feeding it back into the system. I have usually a couple of spare of everything on my shelf, so I can afford to be a bit of a cowboy because I can just grab a spare part. You may have to buy something and wait for it to be shipped. So for that reason, you move your machine around slowly while it's powered down.
Yeah. No, great. Another thing on damaging stuff. Another common thing I've seen on those stepper drives. Sorry if I'm dragging this too long.
That's all right. I'm an expert on the damaging stuff topic. So.
Right. Another thing is, on the stepper drives, you have those little dip switches to change the micro stepping or the amps. Please keep in mind, every time you need to play with those switches, change any settings, switch off your drives, let the caps, die down, and then change those settings. I've seen some of those drives because people are like, okay, my 8 micro steps didn't work. I need to set it to 16, and then they go and change it while it's powered up. A lot of drives, it's a bad idea. You can damage them. So just make sure you power off, change any settings then.
Yeah, if you're going into your control box of your machine, just turn the power off and wait a few minutes. Regardless,
that's the way to go. But I don't know how many of us we do it.
No, man, I actually do it now. I've been dropped a couple of times. Sometimes late at night when I'm the only one around, and it sort of taught me that. It doesn't take long.
Sometimes it's like, especially with stepper motors, because it's like something you have in front, you have access, you're like, it's running on DC volts, and you don't actually, it's one of those things, you're like, hey, I'm just trying to change these settings. I'm going to flick this switch. But it should not make any difference. I don't know how they're designed back in China, but I've seen that if you change those settings while they're powered up, You can damage. You might not burn the drive. That's the funny thing. They become funny, you know, rather than taking 800 steps. If it says it's going to take 800 steps, it might start taking 820 steps, something random. And you'll be just pulling your hair out and you're like, why? I'm giving it 800 steps. Why it's moving less or more, you know? So always keep that in mind. Right. All right, Ben. So what do you say? Do we have everything covered?
Yeah, I'm just having a quick scan through the last little bit of the comments. I can't see anything we haven't addressed. No, I think I'm pretty happy to leave it there. People can email us or put comments somewhere to find us if we said something wrong or we need more info, or if they've got any
exactly. Like a lot of times, guys, we just like you doing stuff, learning, and we also learning so much from this podcast. You know, we get emails and other stuff too. So if there is something wrong, please do let us know. We'll be more than happy to learn and share the information. And we're not any like experts or gurus. You know? We're just sharing our experiences. You know.
Yeah, go and sanity check anything you learn from me, because it's all learned from my experience, not from being an electrical engineer.
Yeah. Good one, mate. That was a good show. And Dave again. Yeah, thanks, Dave. Thanks, Frank. So mate. Hopefully, the next topic is going to be a good one just like this. So please, everyone, let us know what topics you want to have a discussion about. And as we said, it's never too limited to maths. So, excuse me. It's getting cold here. It's never limited to maths or machines or 3D tech. You're trying to keep it very open. It can be anything about tooling or other stuff. If you don't know, we'll try to find someone who knows about it, trying to get them on the show. And go from there. So great.
So ideas for future topics. Anything you'd like covered in future topics? We're looking for ideas too. You can email them to us or just leave them in the follow-up comments on YouTube.
Yeah. Great. Ben, it's always a pleasure to have you here, mate. Thanks for sharing your information on motors. I definitely don't have that much experience on motors, but thank you so much. It's been a great show.
Great. No, thanks very much, everyone, for tuning in.
All right. I need to get some medicine. Yep. So thank you, everyone. And we'll be definitely in touch in the next show. Thank you. Have a good day.
See you guys.